Today we are working on topic 2, solving equations with variables on both sides. Our I can statements for today: I can solve equations with variables on both sides, and I can determine whether equations have no solution, one solution, or infinitely many solutions. So our key idea for today: solving equations with variables on both sides. To solve equations with variables on both sides, collect the variable terms on one side and the constant terms on the other side. All right, so for this example, here's our equation: 15 minus 2x equals negative 7x. And then it says check your solution, which means we need to write down a check. All right, so the first thing we need to do is figure out, what do we have on both sides? Do we have constants on both sides? Do we have variables on both sides? On this one, we have variables on both sides, but only one side that has a constant. So that 15 is going to stay there, and then we need to move this negative 2x to the other side. And if you want to, you could do boom, boom, if it helps you see the negative 2x a little more clearly. Okay, so we need to get rid of that negative 2x. We're going to do that by adding 2x. Just like if this was a plus negative 2 and we'd add 2 to cancel it out. Same thing, but we're adding 2x. I'm going to go ahead and draw a line here so you can see the two sides of my equation. I'm adding a 2x once on each side of the equation. So I'm adding 2x here, and I'm adding 2x here. You can only add like terms. So I'm not adding a 2x to my 15. I'm adding a 2x to this side. Okay, negative 2x plus positive 2x equals 0. So I've gotten rid of the x term on that side. I'm left with 15. Then I'm going to combine my like terms here. Negative 7x plus positive 2x. That's going to equal negative 5x. Different signs, find the difference. More negatives, the answer is negative. Okay, so now that I have this equation, I've got multiplication to cancel out. Negative 5 times x. So I cancel out multiplication with division. So I'm going to divide by negative 5 on both sides. Negative 5 divided by negative 5 is positive 1. So on this side of the equation, I'm left with just the x. And on this side, I have 15 divided by negative 5, which is negative 3. So my solution is negative 3 equals x. Now we're going to check it. We're going to put it back into the original equation. So 15 minus 2, and then instead of x, we're going to do times negative 3. Equals negative 7 times negative 3. Now, I can't just put a check mark and say, yep, I've checked it. I need to actually do the calculations on both sides and make sure I get the same answer. Okay, so I'm going to start by doing a boom, boom here. Then I need to do multiplication. Negative 2 times negative 3 is positive 6. Same sign, answer's positive. 15 plus 6. Over here, I'm going to do my multiplication. Negative 7 times negative 3 is 21. Okay, let's think about it for a minute. 15 plus 6 equals 21. Yep, that's correct. So I solved my equation correctly. Okay, let's take a look at this next one. Now, this one's a little more complicated than our last one because we have numbers to distribute. We have numbers in front of these parentheses. We also have a fraction. Don't worry, it's same steps as what we've done before on our equations. It's just going to take a little bit longer to solve. Okay, so I have negative 2, and I need to distribute that to both parts here. And I'm going to go ahead and do a boom, boom, just so you can see that's a negative 5. So negative 2 times x is negative 2x plus negative 2 times negative 5 is positive 10 equals. Okay, now I have this 6 to distribute. Again, I'm going to do a boom, boom on my minus and just make that look like plus negative 1/2. 6 times 2 is 12. Plus negative 1/2 times 6 is negative 3x. You can think of that negative 1/2 as dividing by 2, or if you want to do the longhand multiplication, look like this: 6 over 1 times negative 1/2. Negative 6 over 2 equals negative 3. Okay, so that's how you can show it with the multiplication off to the side. But if you know 1/2 is like dividing by 2, different signs, the answer is negative, then you don't really have to do all of that work off to the side. 6 divided by 2 is 3. Okay, I now have an equation with variables on both sides and constants on both sides. So really, I can pick any of those terms to move. It doesn't matter which one I choose. Okay, so I think I'm going to pick the plus 10 to move first. I could have picked any one of the 4. I'm just picking the plus 10. I'm going to get rid of it by subtracting 10, just like I have in my other equations. I'm doing it once on each side. I'll go ahead and draw a line here just so you can see my sides. I'm only lining up the like terms. I did it once on each side. I'm not subtracting anything from the x's. I'm only subtracting once on each side, and I'm lining up the like terms. 10 minus 10 is 0. So on this side of the equation, I'm left with negative 2x equals 12 minus 10 is 2. And then I still have this plus negative 3x. I picked this side of the equation for my constants, which means the next thing I have to move is this negative 3x. I get rid of the negative 3x by adding a positive 3x. And again, I'm lining up those like terms. Negative 3x plus 3x is 0. So on this side of the equation, I'm only left with a 2. Negative 2x plus positive 3x is a positive 1x. So x equals 2. They didn't say I had to check my work, but I'm going to go ahead and do it because usually they do ask for a check. I'm just going to do it over here on the other side. Negative 2 times, instead of x, I'm putting my 2. This was a minus 5 equals 6 times 2 minus 1/2 times x, which was 2. Since I have a parentheses in that parentheses, I'm just going to put a bracket around it. Okay, so let's go ahead and try this. I do parentheses first. 2 minus 5, boom, boom, is like 2 plus negative 5. That's negative 3. Times negative 2 is positive 6. All right, let's try the other side. Boom, boom. Negative 1/2 times 2 is negative 1. Okay, 2 minus 1, or 2 plus negative 1 is 1. So then I have 6 times 1 equals 6. Yep, that's true. So we solved it correctly. All right, go ahead and pause the video and try these 3 on your own. Okay, let's check our answers. So here I have negative 3x equals 2x plus 19. So I'm going to start by moving this 2x. I have to do this one first on this equation because I have variables on both sides, but this is the only side for my constant, so I have to keep that there. All right, so I'm going to subtract 2x. On the side, I'm left with 19. Negative 3x minus 2x, I can do boom, boom, negative 3 plus negative 2 is negative 5. So negative 5x equals 19. I have to cancel out my multiplication with division. All right, so let's see. Negative 5 divided by negative 5 is positive 1, and then I have 19 divided by negative 5. I'm going to do off to the side. 5 goes into 19 3 times. 3 times 5 is 15. 19 minus 15 is 4. Okay, I'm going to just do it as a mixed number. So these were different signs. My answer is going to be a negative. Negative 3 and 4/5. I could make it into a decimal. If you're a person that likes decimals, I could have added a decimal, added a 0, brought it down. That's 40. It would have been 0.8. Could have done it either way. Now I need to check my solution. So I think I'm going to erase my long division here just to give myself a little more space underneath the problem to show my check. Okay, so I've got to put in this answer, negative 3 and 4/5, where my x's are. So negative 3 and 4/5 equals 2 times negative 3 and 4/5 plus 19. All right, let's see. For mixed numbers, for multiplication, I need to make them into improper fractions. My whole numbers will have to be impropers as well. So let's see. This would be a -3/1 times 5 times 3 is 15 plus 4 is 19. So that's a -19/5 equals, this is going to be 2/1 times -19 fifths plus 19. Okay, let's calculate it out. All right, I don't see anything I can cross cancel on this one, so I'm going to need to do some multiplication. 19 times 3, let me think for a minute. If it was 20 times 3, then it would be 60, but it's 3 less, so that would be 57. And 5 times 1 is 5. So I have 57 fifths. Same sign, answer is positive. And then let's see, if I was thinking of that as a improper fraction and I want to make it back into a whole number, let's see, 5 would go into 57 11 times with 2 and a remainder. So 11 and 2 fifths, that's what this side of the equation equals. Let's check this side. Okay, 2 times -19 would be -38/5 plus 19. All right, let's see. So -38 fifths, if I make it into a mixed number, looks like I need a little more space here. 5 goes into 38 7 times. It's going to be negative. And that would be 3 fifths plus 19. All right, hopefully equals 11 and 2 fifths. All right, I'm going to keep those as mixed numbers. Different signs, find the difference. 19 minus 7, 3 fifths. I don't have a fraction to subtract from here, so I'm going to borrow. That's going to become an 8. This is going to be 5 fifths. 5 fifths minus 3 fifths is 2 fifths. 8 minus 7 is 1. 1 minus 0 is 1. 11 and 2 fifths, 11 and 2 fifths. So we checked it. It's correct. All right, so now we're going to go back up. I'm going to change colors. Okay, so on this next one, I have constants on both sides. I have variables on both sides. So I can pick any one of those things to move. I'm going to go ahead and do boom, boom here, make that a plus -1. I'm going to move the 2.5y first. Doesn't really matter. You can pick any of those things that you want. All right, so I'm going to subtract 2.5y. I'm only doing 1 on each side of the equation. 2.5y minus 2.5y is 0. I'm left with 6. 4.5y minus 2.5y is going to give me 2y. And then I've got this plus -1. To get rid of the -1, I'm going to add a +1. 6 plus 1 is 7. So I've got 7 equals 2y. All right, then I need to divide both sides by 2. 7 divided by 2 is 3.5. And I could have written it as 3 5/10. Again, depends on if you want it as a fraction or a decimal. Doesn't really matter. Okay, now I need to check my solution. So I guess since these were already in decimals, I'm going to put my decimal form of my answer into my equation to check it. So let me move this. I'll write it and then I'll move it. I guess, okay, I had 2.5 times y, so that's 3.5, plus 6 equals 4.5 times y, 3.5, minus 1. Okay, now I'll move it. Okay, so I need to do 2.5 times 3.5 first. I don't know those off the top of my head, so I'm going to have to set it up over here. 2.5 times 3.5, I'm thinking 25 times 35. 5 times 5 is 25. Write the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Bring down a 0, cross that out. 5 times 3 is 15. 3 times 2 is 6, plus 1 is 7. 5 plus 0 is 5. 2 plus 5 is 7. 1 plus 7 is 8. 1, 2 decimals in the problem, 1, 2 decimals in the answer. That's going to be 8 and 75 hundredths plus 6. That's going to give me a total of 14 and 75 hundredths. All right, now I need to try the other side and see if I get the same answer. So I need to do 4.5 times 3.5. So we'll do it over here. 4.5 times 3.5. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. 0 placeholder. 5 times 3 is 15. 3 times 4 is 12, plus 1 is 13. 5 plus 0 is 5. 2 plus 5 is 7. 2 plus 3 is 5. Bring down the 1. 1, 2 decimals in the problem. 1, 2 decimals in the answer. 15 and 75 hundredths minus 1 does equal 14 and 75 hundredths. So yes, we've checked it. Yes, it's correct. All right, whew, last one. So I have 6 times the quantity 4 minus z equals 2z. So I need to start by doing distributive property. All right, boom, boom. 6 times 4 is 24. 6 times a negative z is going to be negative 6z equals 2z. All right, I only have one side with a constant. I have two sides with a variable, which means I have got to move this plus negative 6z first. I do that by adding a positive 6z because negative 6 plus positive 6 equals 0. Okay, so those cancel out. I'm left with 24. Here I'm doing 2z plus 6z. That's going to give me 8z. Then I cancel out the multiplication with division. 24 divided by 8 equals 3. 3 equals z. Nice whole number. That's going to make my checking just a little bit easier than the last two. All right, so I got to put it back in. 6 times 4 minus z, which was 3, equals 2 times 3. Okay, parentheses first, 4 minus 3 is 1, times 6 equals 6. 2 times 3 equals 6, so 6 equals 6, yep, that's correct. All right, let's take a look at our next one. So here I have 3 minus 4x equals negative 7 minus 4x. You can pick anything you want to move. I'm going to move my variable first. Minus 4x. I'm going to get rid of it by adding a positive 4x. Negative 4x plus positive 4x equals 0. On this side, I'm left with 3. Negative 4x plus positive 4x, could have done boom, boom, is also 0. I'm left with negative 7. 3 does not equal negative 7. That is a no solution equation. If you see an equation like this one, and I'm going to go back and erase my writing in the first part so you can just see the equation, the original equation a little bit better. I have the same variables with the same coefficient, negative 4, but the other numbers are different. And when you have equations like that, there's no number that is going to work. If I have 0 here, 3 minus 0 is 3, negative 7 minus 0 is negative 7, that it can't ever work. You're not going to have the same number and be able to add 3 or 7 to it and get the same, get an answer. So this is a no solution equation. All right, let's take a look at this one. 6x plus 4 equals 4 times 3 halves x plus 1. All right, so 6x plus 4, I'm just going to rewrite. 4 times 3 halves x, and the 1 I need to distribute. I'm going to do the fraction multiplication off to the side. I do need to make that 4 a 4 over 1. So 4 over 1 times 3 over 2. 4 times 3 is 12. 1 times 2 is 2. 12 divided by 2 is 6. Okay, so that's 6x. 4 times 1 is 4. Now you might notice something here. Both sides are the same. 6x plus 4 equals 6x plus 4. Let's say I don't see that right away and I subtract 6x. Then I'm left with 4 equals 4. So that is an infinite solution no matter what number you pick for x. Whoa. Helps if I actually write all of the letters. Let's try that again. Infinite solution. No matter what number you pick for x, both sides will stay equal. Go ahead and pause this video and try these next two. Okay, let's check our answers. For number 4, I'm going to start by moving the 2x. I'm going to do that by subtracting 2x. 2x minus 2x is 0. I'm left with 1. 2x minus 2x is 0. I'm left with negative 1. 1 cannot equal negative 1. No solution. For number 5, that 1/2, remember that's like divide by 2. Got to distribute. 1/2 of 6t is 3t. 1/2 of negative 4 is negative 2. Both sides are the same. 3t minus 2 equals 3t minus 2. That means it's going to be infinite solutions. All right. Let's take a look at our story problem here. A boat travels X miles per hour upstream on the Mississippi River. On the return trip, the boat travels 2 miles per hour faster. How far does the boat travel upstream? Okay, so we want to know how far it's traveling, and in order to figure that out, we need to calculate with its speed. Okay, so X miles per hour, that's what our variable is standing for. Okay, so X miles per hour upstream for 3 hours. So let's say they were going 10 miles per hour. For 3 hours, I would do 10 times 3, that's 30 miles. But I don't know what that is, it's X, so I'm just going to write 3 times X. And then on the back here, it is 2.5 hours. But plus 2 hours, 2 miles per hour faster. So if this was 10 miles per hour, then this would be 12. I'm adding 2 to that X value, and I had to put it in parentheses because I'm not adding it to the whole expression. I'm adding it just to the X part. So 3 hours times X miles per hour, and then 2.5 hours times our new speed of X plus 2. Okay, so now I have my equation. I just need to solve it. So I'm going to start with distributive property. 2.5 times X is 2.5X. 2.5 times 2 is 5, equals 3x. All right, now I'm going to get rid of my 2.5x by subtracting. If it helps, you can write that 3x. I'm going to rewrite it with a decimal since I'm doing decimal subtraction. Make it 3.0x. Minus 2.5. 2.5 minus 2.5 is 0. I'm left with 5 on this side. And then I have 3.0 minus 2.5. Borrow from the 3, make that a 10. I didn't do a great job of lining up my decimals, but that's okay. 10 minus 5 is 5. Bring down the decimal. 2 minus 2 is 0. So I have 1/2 x equals 5. I've got to divide by that 5/10. Since I'm doing decimal division, I need to move my decimal over one place there, which means I need to add a placeholder 0 there. 50 divided by 5, I'm going to get 10 miles per hour, which is just what I made up to kind of help us reason the problem, but it turned out to be the correct answer. So 10 miles per hour is the speed. Oh, wait, hold on. I'm going to erase my box. X equals 10 miles per hour. That is the speed. However, the question says, how far does the boat travel? It didn't say what speed. So now that I know the 10 miles per hour, it went up river 3 hours. So my final step on this one is to do 3 times 10 to figure out the distance, which is going to be 30 miles. All right, let's look at this next one. A boat travels X miles per hour from one island to another island in 2.5 hours. The boat travels 5 miles per hour faster on the return trip of 2 hours. What is the distance between the islands? So this is the same type of problem as the last one. We'll get the equation set up together, and then I'll have you pause and finish it on your own. Okay, so X miles for 2.5 hours. So 2.5x. The return trip was 2 hours, but now it's 5 miles per hour faster. So I'm going to do x plus 5. And then we have to find, once we solve for x, then we have to find the distance. Okay, go ahead and solve this problem. Okay, let's check our answers. So I need to distribute here. 2 times x is 2x. 2 times 5 is 10. I have 2.5x. Okay, I'm going to subtract 2x. Subtract 2, I'll add a decimal and a 0, so my decimal's lined up. 2 minus 2 is 0, so I'm left with 10. 5 minus 0 is 5. Bring down that x, bring down my decimal. 2 minus 2 is 0, so I have 1/2 x, or 5/10 x equals 10. Gotta divide by 5/10. Okay, move my decimal 1 here, move a decimal here, and add a placeholder 0. So really I'm doing 100 divided by 5, which equals 20. That's the speed, 20 miles per hour. And then it is 2.5 hours. So I'm multiplying by 2.5. 5 times 0 is 0. 5 times 2 is 10. 0 placeholder. 2 times 0 is 0. 2 times 2 is 4. 100 plus 400 is 500. 1 decimal in the problem. 1 decimal in the answer. So we have 50.0, which is 50 miles. All right, and then our last one, give an example of an equation that has no solution, one solution, and infinitely many solutions. Go ahead and pause the video and write down an example for each. All right, let's check our answers. So no solution means my coefficient and my variable are the same, like 2x, but the numbers after are different. So 2x minus 1 equals 2x plus 5. 2x, number, coefficient and variable are the same. The second part of the equations are different. No solution. One solution has coefficients on your variables that are different. So it could be something like 2x minus 1 equals 3x plus 2. As long as the coefficients on my variables are different, I'm going to have one solution. And then infinitely many solutions is when my coefficients are the same and the other parts of the equations are the same as well. Usually when they show you that, let's see, I have 6x plus 3 equals Usually they'll show you one of them not exactly. Like you'll have to do a calculation before you see right away that it's the same. So 3 times, say, 2x plus 1 would be an example of infinite solutions, because once you distribute that part, 3 times 2x is 6x, 3 times 1 is 3, then you see how both sides are the same. That's going to be an infinite solution equation.